Where did it all begin? How old is everything we see? And what if the answers we've clung to are wrong? In 2023, NASA's James Webb Space Telescope, one of the most powerful instruments ever built to observe the heavens, delivered a revelation that stunned scientists and sent shock waves through the astronomical community. It wasn't just another galaxy or a distant planet. It was a star, a celestial object that might be older than the universe itself. That's right, a star whose estimated age suggests it may have formed before the very fabric of reality as we understand it. This mind-bending discovery has forced scientists to revisit their most basic assumptions and grapple with a question that seems to belong more to science fiction than science fact. How can a star be older than the universe? Is it a measurement error, a freak of physics, or a clue pointing toward a radically different understanding of the cosmos? Roughly 200 light-years away, near the constellation Libra, lies a star unlike any other known to astronomers. As HD 140283, but more famously called Methuselah, named after the biblical figure who reportedly lived 969 years, this star is a relic of the early universe, a survivor from a time long before Earth even existed. What makes Methuselah so extraordinary isn't just its age but the paradox it presents. Initial estimates placed the star's age at a staggering 16 billion years, which raised immediate eyebrows in the scientific community. More recent measurements, utilizing cutting-edge observational techniques, refined the figure to about 14.46 billion years, give or take 800 million. And here's where the real mystery lies. According to the most widely accepted cosmological model, the universe itself is only 13.8 billion years old. If Methuselah really is older than that, we're either grossly misjudging the age of this star or the universe is far older than we've been led to believe. To unravel this conundrum, we need to understand how we even calculate the age of the universe. The prevailing model begins with the Big Bang, that initial moment of explosive creation roughly 13.8 billion years ago, which sent all matter and energy hurtling outward into what would become the cosmos. By observing the light from distant galaxies, specifically how this light is stretched toward the red end of the spectrum, a phenomenon known as redshift, astronomers have been able to determine how fast the universe is expanding and, from there, estimate its age. Measurements of the cosmic microwave background, the faint afterglow of the Big Bang, have further confirmed this figure. If we were to compress the universe's entire history into a single calendar year, the Big Bang would occur on January 1st, Earth would form sometime in late December, and all of human history would occupy only the final seconds of December 31st. That's how ancient 13.8 billion years truly is. But Methuselah's age doesn't fit within this tidy timeline. If it is indeed older than the universe, something is clearly amiss, either in the methods we use to date stars or in our understanding of cosmic history itself. This is where the provocative theory of physicist Rajendra Gupta from the University of Ottawa enters the frame. Gupta proposes that the universe may not be 13.8 billion years old at all, but rather a whopping 26.7 billion years old, nearly twice the age long accepted by mainstream cosmology. His theory fuses two intriguing ideas: the tired light hypothesis, originally proposed in 1929 by Swiss astronomer Fritz Zwicky, and the possibility that fundamental physical forces have changed over time. The tired light concept suggests that photons, the particles of light, lose energy as they traverse the vast stretches of intergalactic space, resulting in a redshift that isn't solely due to the expansion of the universe. If redshift is caused both by the stretching of space and by the loss of photon energy, then the universe could be far older than previously calculated. Gupta takes this further by suggesting that forces like gravity and electromagnetism may not have always behaved the way they do today, a controversial idea first hinted at by theoretical physicist Paul Dirac. If these forces have evolved, it could reshape our entire understanding of time, space, and the life cycles of stars and galaxies. And Gupta's model offers one possible resolution to the Methuselah paradox, as well as to other perplexing discoveries from the James Webb Space Telescope, such as the presence of well-formed galaxies just 300 million years after the Big Bang, when the universe as we currently understand it shouldn't have had time to evolve such complexity. It's like finding a child running a Fortune 500 company, not impossible, but highly improbable. These early galaxies appear too mature for a universe that's supposedly still in its infancy at that time. Gupta's revised cosmic timeline gives the universe much more breathing room to develop, which could help explain these anomalies. And if is right, it might also resolve long-standing tensions in cosmology, such as the infamous Hubble constant problem, where different methods of measuring the universe's expansion yield inconsistent results. So how do astronomers even determine the age of a star like Methuselah? After all, stars don't come with birth certificates. Scientists rely on indirect clues, like a star's brightness, color, composition, and spin. One method, known as gyrochronology, is surprisingly intuitive. Stars slow their rotation as they age, much like a spinning top winding down. By measuring a star's rotational velocity and comparing it to established models of stellar evolution, researchers can estimate its age. Methuselah rotates slowly and has an extremely low metallicity, meaning it contains very few elements heavier than hydrogen or helium. This tells us it formed in a time before the universe had produced many heavy elements in supernova explosions. Everything about it screams ancient. Yet the numbers seem to shout impossible. Either the star's age is being miscalculated or the entire framework of our cosmic timeline needs recalibration. If Gupta's 26.7 billion-year-old universe proves to be accurate, it would mean rethinking our cosmic calendar. Humanity's brief history would become an even tinier fraction of time, more like 5 seconds before midnight on December 31st. But beyond the philosophical implications of our smallness in the grand scheme, a revised age could help address inconsistencies in our models of galactic formation and the behavior of the early universe. It could explain why the James Webb Telescope is seeing galaxies that seem to exist before they should, and offer new insights into how quickly stars and structures formed after the Big Bang, or whatever preceded it. Not everyone is convinced, of course. Gupta's theory is not without its critics. Some argue that it conflicts with well-established data from the cosmic microwave background and decades of observational cosmology. Still, even skeptics agree that it's sparking necessary debate, pushing the boundaries of what we thought we knew and opening the door to new possibilities. Meanwhile, another mystery is unfolding closer to home. The European Space Agency's Gaia satellite, which has been mapping the position and motion of nearly 2 billion stars in the Milky Way, has detected something odd. Stars in the outer regions of our galaxy are moving more slowly than expected when compared to stars in similar positions in other galaxies. This is significant because a star's velocity helps astronomers estimate the mass of the galaxy. The faster the stars move, the more mass, be it stars, gas, dust, or dark matter, is presumed to be holding them in orbit. Gaia's data suggests that the Milky Way's mass is about 200 billion times that of the Sun, which is still colossal, but only 1/5 of what previous estimates indicated. This discrepancy raises serious questions. Could it be that our galaxy has significantly less dark matter than we thought? Dark matter, the elusive substance that doesn't emit or absorb light but exerts gravitational influence, is thought to make up a large portion of the universe's mass. If the Milky Way lacks the expected amount of dark matter, it could mean our galaxy is a cosmic oddball, or that our entire understanding of dark matter is flawed. Alternatively, the methods used to estimate galactic mass or interpret Gaia's data might need refinement. Estimating galactic mass is notoriously tricky, and even a small error in the data or analysis could lead to large discrepancies. For now, astronomers are digging deeper, cross-referencing Gaia's findings with other observations and simulations in the hope of finding clarity. The implications of less dark matter, or a redefined dark matter model, could ripple through everything we know about galactic dynamics, cosmic structure, and the evolution of the universe. As we zoom out to consider these developments together, the Methuselah paradox, Gupta's radical theory of a 26.7 billion-year-old universe, and the unexpected mass of the Milky Way, they begin to look less like isolated oddities and more like interconnected pieces of a vast cosmic puzzle. Each one challenges assumptions that have shaped our view of reality for decades. Methuselah, with its ancient light, serves as a messenger from a time long gone, whispering that our cosmic clocks might be misaligned. The James Webb and Gaia telescopes are the new eyes through which we peer into this unknown. The revelations, both thrilling and bewildering, show us that whether the universe is 13.8 billion years old, 26.7 billion, or governed by forces we haven't even begun to understand, one thing is certain: we are only at the beginning of our journey to uncover the truth. Scientists will continue to probe Methuselah's strange age, explore Gupta's controversial model, and decode the mysteries in Gaia's stellar atlas. Somewhere out there, amid the stars and darkness, the answers await. Until then, we keep looking up, because every new question brings us one step closer to understanding the universe and our place within it. As the scientific community absorbs the implications of these revelations, a broader realization is beginning to take hold. The universe may be far more complex, layered, and mysterious than our current models can encompass. While Gupta's theory offers one potential resolution to the Methuselah paradox and the appearance of prematurely evolved galaxies, it also opens a Pandora's box of new questions. For example, if the physical constants that govern everything from stellar fusion to gravitational interactions have evolved over time, how do we recalibrate our entire framework of physics to account for such change? Could the fundamental equations of general relativity or quantum mechanics themselves require revision? This concept, that constants such as the gravitational constant or the fine structure constant might not be truly constant, has been proposed before, but it has long existed on the fringes of theoretical physics. Now, however, it is being propelled into mainstream consideration by empirical anomalies that our most precise instruments are uncovering. The James Webb Space Telescope's infrared eyes are revealing a universe that seems more mature, structured, and crowded than expected in its infancy. Meanwhile, Gaia's unparalleled star mapping is exposing discrepancies in the Milky Way's behavior that can't be easily brushed aside. Another ripple effect of these findings relates to stellar archaeology, the study of the oldest stars in the galaxy to understand its earliest epochs. If Methuselah is not alone in its apparent antiquity, it suggests there could be many other ultra-old stars waiting to be reanalyzed. What we consider metal-poor stars, those with extremely low quantities of elements heavier than helium, may hold the keys to unlocking not just the history of our galaxy but of the entire cosmos. And if stellar evolution itself must be re-evaluated due to changing constants or unrecognized variables, our understanding of stellar life cycles, from birth in nebulae to death as white dwarfs or supernovae, may need to be rewritten from the ground up. Beyond the scientific implications lie the philosophical ones. Humanity has long sought to place itself within a comprehensible cosmic story, one with a clear beginning, middle, and perhaps even an end. But the more we discover, the more that narrative shifts. A universe nearly 27 billion years old dramatically lengthens the timeline of cosmic history. In such a universe, civilizations might have risen and fallen countless times across galaxies. The possibility exists that intelligent life, even advanced civilizations, could have emerged, vanished,